All right, so our first job is to decide, it says graph the data in the table, and then decide whether the function is linear or nonlinear. So let's go ahead. I'm going to use my freehand tool here. -2, 4 would be over here and up here. 0, 0 is right here. 2, 4 is over here. Already it's looking a little zigzaggy here. And 4, 16 would be way off the page, and I'd end up with some kind of weird shape like this. So I'm thinking that this is not linear. If I try to connect the dots and follow this pattern, it looks kind of like this. So I would say no, not linear. Let's make sure we get that on here, non-linear. Okay, all right, let's look at the next one. Go ahead. Let's plot the points on this one. -1, -1 is right here. 0, 1 is right here. 1, 3 here, and 2, 5 is just off the graph right here. But when I'm looking at that one, I definitely think that I've got a straight line going on here. So I'm going to see if I can just draw this line right through here and if it actually will line up. And it looks like it does. Okay, so that one is linear. Write that here, linear. Right, okay. So next, does the graph represent a linear or nonlinear function? Explain. So this is not a whole lot of rocket science right here. This is a straight line. So I'm going to write linear because it is a straight line and has a constant rate of change, right? That's what it takes to make something linear. You have to have a constant rate of change. And then finally over here, is this one linear? No, non-linear. It's got that bend in it. It really is. It's just kind of a bend. It's not really a curve. And if you look over here, the rate of change on the left is negative, but the rate of change on the right is positive. And the slope or rate of change changes from negative to positive. So definitely not a linear function, not a straight line. Okay, last one, just this is a real quick thing. The table shows the area of a square with a side of length x inches. So that's meaning that, obviously I'm making a square, and it's telling me that when you make that square, to find the area, you do the side, right? Side times side. So side times side, that's going to give me side squared, right? So the area is side squared. So anyway, does the table represent a linear or nonlinear function? Well, if I look at the change in y, this is different from each number to each number. This one's 3, this one's 5, this one's 7. That's how y is changing, but we can't really tell what's going on until we look at how x is changing. X is changing by 1 here, and changing by 1 here, and changing by 1 here. So definitely we go from a slope of 3 over 1, here's that rate of change, right, to 5 over 1, which is not equal to 3 over 1. And then we have 7 over 1, which is also not equal. So if I'm going to say, if I have to explain this, then I think I've done my due diligence in trying to explain. This is nonlinear because the rate of change is not constant, right? It changes from 3 to 5 to 7. as the table increases. I guess we can say something like that. All right, so pretty simple, straightforward, linear versus nonlinear.